In this video, I'm going to talk about the regression equation. So, suppose we have some data. I have a scatter plot right here of third exam scores of a student and then their final exam score. And I'm wanting to see if there's a correlation between them. We can kind of see that as the third exam score increases, their final exam score increases somewhat too. It's not a hard, fast rule. As you could see, we have this data value here that happens to be the lowest third exam score, but they scored pretty decently on the final. But that's not always the case. It seems to be that for the most part, the lower they do on the third exam, the lower they do on the final. The better they do on the third exam, the better they do on the final. And what we want to do is almost visualize a line going through this data. We call that line the least squares regression line, or the line of best fit. And you can almost kind of imagine the line going right through the middle, right? You want some data above it and some data below it. So here's what the least squares regression line would look like. This is the same data except it's zoomed in a little bit, so we're looking at it a little bit closer. And as you could see, some data is above the line, some data is below the line, and some data is on the line or very close to being on the line. So how do we find the least squares regression line? Here's the formula. By the way, we call this y hat, this y with this caret symbol above it. And you could see that we've defined it to be slope and y-intercept, where A in this case is the y-intercept and B is the slope. And here's how we'd find A. We would find the mean of some y values and the mean of the x values and multiply by B, where B is this formula. Now this formula is very complicated. This takes each data value, subtracts its corresponding mean, multiplies them, adds them all up, and then divides by this formula here. So it's a very complicated formula. We will be using the calculator. And on the calculator, we're going to go to Stat, Calculate, and we're going to use number 8, ln reg, and it's in the form a plus bx, just like our formula. So let's see how this would work. Here's the example, the same data that we saw on the scatter plot in the beginning, third exam scores and final exam scores. So the first thing you want to do is enter this data into the calculator. To do that, you go to Stat, the very first option, Edit, and you're going to enter the x values into L1 and the y values into L2. I've already done that to speed us along. It's smart to put them into L1 and L2. That way, when we run ln reg, it'll be easier because it automatically defaults to L1 and L2. Okay, so let's actually go ahead and run that. So we're going to go back to Stat. This time, though, we're going to arrow right to Calculate. And we're going to use number 8 here, ln reg a plus bx. Now I want to pause here for a second and point out that number 4 is also ln reg. It just switched the a and the b. In other words, in this problem, a is slope and b is y-intercept. But down here, a is y-intercept and b is slope. They actually are exactly the same. In other words, if you were to use number 4 instead of number 8, you're going to get the same slope and y-intercept. It's just the way the calculator has chosen to label those values. We're going to use number 8 just so it's consistent with the formula we saw on the previous page, which is the formula from the textbook. So we're going to use number 8. I'm going to go ahead and hit number 8. And you'll notice that right away it is defaulted to L1 and L2 as the Y list. So we're going to arrow down to Calculate. We have to do nothing else. And this is our least squares regression line. Now I'm going to pause for a second and mention that some of the older calculators don't show that menu you just saw. In other words, it goes right back to the home screen. As long as you plugged in the x's into L1 and the y's into L2, if you hit enter, you'll go ahead and find the same result. If you don't, you will have to actually enter that data, and you might want to find a different YouTube video that shows how to do that on the older calculators. Okay, so I'm going to go ahead and write down the least squares regression line. I've rounded to 2 decimal places. And you'll notice that I'm asked to interpret the slope and the y-intercept. So I'm going to do that. I'm going to start with the slope. First, I'm going to round the slope. And I'm going to think of slope as 5 over 1 because we typically think of slope as rise over run, or the change in y's over the change in x's. So in this case, when it's a 5, that's referring to the change in the final exam score. And this, a 1, is referring to the change in the third exam score. So here's how we'd interpret this. For an increase in 1 point on the third exam, you can expect the final exam score to increase by about 5 points. Now, you didn't have to round to 5. If you really wanted to use 4.83, you can use 4.83 in the interpretation. It's just a cleaner interpretation if we round it. But this is how we'd interpret these. For each 1 point increase or 1 change in the x value, we expect a certain change in the y value, and that is the slope. Now let's look at the y-intercept. The y-intercept, negative 173.51, we get the y-intercept when we plug in 0 for x. 0 for x is going to give me this value. What that means then is getting a 0 on the third exam score, and then we get out a negative value. Well, that doesn't really make sense. We don't get negative exam score values. So in this case, it's not appropriate to interpret the y-intercept. Now that's not always the case, but in this problem it most certainly is, and the reason happens to be because of the type of data we're looking at. I see that the lowest data value is 65 and the highest data value is 75. So this line is based on data between 65 and 75. So when we leave that range of data, we kind of lose our accuracy of the least squares regression line. So plugging in a 0 doesn't make sense to it because it never took 0 into account when it created this equation. So if we happen to get a data point that does have 0 for the third exam and what they scored on the final, this will change and might be able to then predict what would happen if you got a 0 and what type of score you could expect on the final exam. So sometimes it is appropriate to interpret the y-intercept, but in this particular problem, it just doesn't make sense.